I've wanted to make a live edge slab table for several years, so when a friend asked me to build just that for their new apartment, you can imagine my excitement. This is European oak, milled and dried by a local sawyer. I'll put their Facebook page in the description. They were actually about a meter longer than this when we picked them up, but I crosscut them to rough length to make them easier to handle before hogging off the chainsaw marks with one of my few power tools. They were remarkably flat apart from the mill marks, which I think is amazing for such huge boards. I ripped off one edge from each slab, first cutting as deep as my circ saw will go and then finishing the cut with a handsaw. This will be the center seam of the tabletop where the slabs join. At this stage enough wood had been removed to make them fairly manageable for my scrawny arms, and most of the messiest work was complete, so I took it inside the shop to joint the sawn edge with a number 7 hand plane. When gluing up panels, I will often make a sprung joint, which means planing a very slight hollow along the length so the boards bend in the clamps and spread the pressure along the entire length. With boards this size, that's not an option. The edges need to be dead flat or the joint won't close. Next, I had some epoxying to do. I don't consider this an epoxy table. I think I poured a total of 300 grams, so it really isn't much. But there were a few cracks and knots that the customer requested black epoxy for. I think it was an excellent choice for these relatively small voids. I taped the underside and did a first pour of clear to seal the wood to prevent staining with the pigmented stuff later. I really should have applied this sealer coat over much more surface, as I wasn't as precise with the black pour as I had hoped. But it turned out okay, and I've learned to be more generous with the clear epoxy now. So for the tinted batch I added 4% black oxide pigment to the mix, and I had to do 2 pours with this as the first did seep into the fibers a little bit, despite the seal coat. But when the last pour was hard, I could do the glue up. This looks a bit weird right now, but I'm attaching glue blocks along the edge. I don't have clamps long enough for this tabletop and no ratchet straps, so the method I came up with was these blocks, which are paired with another on the other slab and set slightly below the edge, so there's a gap between the 2 blocks opposite each other. So when the slabs were in position, I could drive screws through the blocks and squeeze the joint that way. It would have worked to put regular small clamps across the blocks too, but it's hard to get enough pressure on them when the handle is so close to a surface so you can't wrap your hand around it properly. And with the screws it went a bit faster. This is a labor-intensive method, but it worked really well, and I think I'd use it again if gluing up weird shapes that are difficult to get a clamp across. But it does depend on having enough extra thickness in the boards, so it doesn't matter that you have blocks glued directly to the surface. Then it was back to the power planer to get rid of the step at the glue line, the blocks and the excess epoxy. And after that, joint the plane to get rid of the power planer marks. There were these cut-off limbs that we decided to round over to make it more comfortable to be around. So I found a pleasing arc using a string and my finger as a movable pivot point and shaped it. The underside of the rounded areas got a big chamfer as they looked too heavy at full thickness. I actually did this later when the tabletop was flipped to minimize the number of times I had to move it, but it makes more sense to include it here. I never found a great way to clean up the live edge, but I used a gouge to remove the soft underbark and then just very coarse sandpaper to scuff off the stringy texture that was left. I tried to use a wire brush too, but it didn't really do anything except create scratches. The ends were cut to final length now by referencing square against the glue line. Then it was time for smoothing. The grain direction varies a lot in pieces this big, so I got to stretch my hand plane tuning to the limit here and refresh the edge many times before the surface was good. Some spots still needed card scraping. I smoothed the ends with my low angle plane, chamfered the underside, and then the tabletop was done for now. Onto the legs and these parts that connect them, I'll call them rails. These are the offcuts from the two slabs. Here I'm laying out the components for the base and trying to avoid the biggest defects. It's really nice to be able to use the same tree for all parts of a build so the colors look consistent. I wasn't quite able to do that here, but almost. So I got 4 legs and 4 rails from those offcuts. All need to be dimensioned and trued up all around, which is done with winding sticks, square and frequent honing of the jointer and smoother. The rails are also resawn to thickness. Then, with everything squared up, I could start the joinery. The legs are splayed at 5 degrees, which is not much, but enough to be noticeable without looking exaggerated. I went with bridle joints here, as it gives a lot of glue surface and a lot of shoulder area to resist the torque that a splayed leg exerts on the connection. Some of you might remember this saw, the first one I made my own handle for. I originally filed it as a small tenon saw, and it was just in an awkward place in between the dovetail and larger tenon. But I've sharpened it for crosscut since then, and now it's one of my most used saws. The bridle socket in the leg is just a bit deep for my large tenon saw, so I used a panel saw with rib teeth and chopped the waste with a mortise chisel following the 5-degree angle by eye. And a dry fit. I still rarely get joints perfect first try, so I always test before gluing. In this case it was also necessary in order to find the shoulder locations on the other rail. With the joinery done, I could taper the ends of the rails, a detail that works very well with the angled legs in my opinion. This whole design is heavily influenced by James Wright's dining table, an incredible piece with a fantastic video series covering it. I'm sure anyone watching me is also familiar with Wood by Wright, but if not, it's one of the channels that has taught me the most and still one of my favorites. I'll link to his table up in the corner. Let's move on to the long stretchers. I'm not quite done with the rails, but I need to work on the long beams before I can lay out the last joinery needed in the leg sections. This will be half laps with a modification. So I'll start by measuring out the space needed for 2 people side by side and then use the lower rail to knife the exact width of the joint. This socket is too deep for my router plane, so small paring cuts with a chisel is the best way to get it flat. And here's the modification to the joint. I'll cut down only a couple of millimeters to extend the shoulder all the way across the stretcher to add more support against racking forces. Without this, I feared that the leverage from the leg and rail assemblies could twist this joint if the table was pushed from the short end. With this extra shoulder, it felt very solid when assembled. And here I'm transferring the half-lap location to the rails. The stretchers are clamped together with some straight scraps to stay in plane with each other, and then I measured and tapped the ends to get them centered. The thin vertical pieces actually look kinda good, I think. I'll file that away for a future design. The final thing I need to do to the rails is cut some shallow mortises for buttons to sit in. This is how the top will connect to the legs. The length of these mortises is not critical, it just needs to be a little wider than the buttons to allow movement. And the depth doesn't matter too much either. What's important is the distance from the top of the rail, so that the buttons actually pull the tabletop tight to the base when screwed in. Then I could do the final smoothing and remove the last pencil marks. Here you can see how I start by not taking a shaving at all, spinning the depth adjuster while moving it plane, so I feel the very moment the blade engages into the wood and take the finest cut I can. A small chamfer to take away the sharp edges, and then I could glue up the leg and rail assemblies. I'm using polyurethane glue for its lubricating properties. These joints are not super easy to push together, and I feared PVA would cause them to seize up too soon. Gloves may be unnecessary, but I don't like getting this stuff on my skin. I'll clamp the joint across the bridle to prevent the expanding glue from pushing the cheeks apart. Not something I've ever had happen, but rather safe than sorry with glue-ups. And now the central X-brace. This is also for racking resistance, and in hindsight was probably not needed together with the shoulder half-lap, but the customers like the look, so consider it a design choice if you will. I had to grab material in the stash for these as well as the long beams, and the X-brace does blend in a little bit worse. I think this is probably white oak and not European. Half-laps again for these, finding the center, knifing around the component and carrying the line across with a square. Here I have the base assembled and elevated off the bench, so I can find the spot for the X-brace and mark shoulders for tenons. I'll also make a small knife mark on the beam where the brace intersects, so I know where to place it later to locate the mortise. With the tenons finished, I glued the X together with PVA wood glue this time. Then, since I had those knife nicks to guide me, I could draw the outline of the tenons onto the beams and follow those lines with a mortise chisel. And with that, all joinery is cut on the beams, so I finished them off with tapered ends. The upper of the long stretchers also need clearance holes for screws to connect it to the tabletop. I find it much easier to drill straight with a bit and brace than an electric drill, so it's my preferred option when a hole really needs to be accurate. The tapered end meant these holes had to be at an angle, so I drew a line to guide me and then carved a sort of pocket for the washer head on the underside. So not only does this table have epoxy, it's also assembled with pocket holes. I'll hand in my resignation right away. An adjustable square is useful for checking that they don't protrude too far. And then the slab had to go back up on the bench again so I could transfer the screw locations. I decided to just pencil around the stretcher as a way to locate the top. This was quite naive, as it would prove very difficult to find the pencil lines under the oil finish and shadow during final assembly. A better way would have been to make a very shallow groove that the stretcher fits into for a solid registration. Another lesson for the notebook, and it did go together in the end, it just took more fiddling than I liked. And this is the last glue up. I did this with the leg assemblies in place to make sure everything would be aligned correctly, though there is no glue between rail and stretcher here. The table is designed to flat pack because of things like normal sized doors. Again, the polyurethane glue here for ease of assembly, and clamps across the mortises to keep the glue from pressing the walls outwards. While I had the top upside down, I decided to finish the underside. I'll be using Osmo, but I wasn't sure I had enough for all these surfaces, so rather than wait for a new can to arrive, I put a different brand on the underside. The oil part of this is probably mostly linseed, as it looks a lot more yellow than the Osmo, but I assume it'll have similar moisture blocking characteristics since they're both wax oils. And it was good that I did this, because my Osmo did indeed almost run out later. I made sure not to touch the sides or bevels with this, to not have any overlap with a non-yellowing top finish. I gave the other parts a light sanding on the edges as the last step before finish. And this is the wax oil I'll use for all visible parts. I made a sample with a few finishes on an offcut, and this was the least yellow finish I had, which in this case was desired. It's also food safe and buffs to a quite smooth surface with a pleasant soft sheen. If applied with a brush, it can be cleaned with turpentine and be reused many times. I've had problems with oak when it comes to buffing the finish. Steel wool and fabric rags both leave little fibers stuck in the coarse grain for me, and wax isn't hard enough to sand. What I do now is use heavy brown paper, like the stuff often used for packaging material. It's just abrasive enough to polish, but not so much that it cuts through the finish. Gives a pretty good surface, I think. And then my friends came with a trailer and picked it up.